So today we are going to factor polynomials, and we are going to use the same type of factoring techniques that you used when factoring quadratics, also when you are factoring polynomials. So let's look at this expression. So right now you have a different degree, you have a degree of 4, but you should treat it the same way as if you were factoring a quadratic. So place the appropriate terms in the boxes and in the corner of your area model. Now you need to think about what two things can you multiply together to get you x to the 4th power, and that's x times x. Remember, when you multiply like bases, you are adding those exponents together. Now you think about what two numbers multiply to a positive 21, but then add to a negative 10, and that gets you negative 7 and negative 3. So when we finish our inside of our box, we see that it does check out, and we can write our two factors as x squared minus 7 and x squared minus 3. If we look at a different example, here you have a binomial, and what you should see is that you could actually factor out a GCF. And that's going to get us a 6x on the outside and then a 4x squared minus 1. What you should see is that you actually have a difference of perfect squares. So that 4x squared minus 1 is actually going to break down into 2x and 2x, and then 1 and 1. So remember, difference of squares, we're taking the square root of each term. And always remember that one of your parentheses has to be a minus and the other one has to be a plus. So as I write my final answer, I can't forget to write my GCF in front, and then I have 2x minus 1 and 2x plus 1. The next you will see you actually have 4 terms. So when we have 4 terms, we're actually going to factor by grouping. And when you factor an expression that have 4 terms, you can also use the area model. What we're going to do is we're going to look for pairs of terms that have common factors and then put them in the same row. So I'm going to take my first 2 terms because they also have a common factor, and then the last 2 terms. And then I can factor out the GCF of each row and put it on the left-hand side. And then you can go ahead and fill out the top 2 of my columns. Now we get x and then a minus 1. So as you write your factors, you're going to see x squared minus 9 and then x minus 1. What you should see is that you actually again have a difference of perfect squares. So that x squared minus 9 becomes x and then 3 and 3. And as you write your final answer, you're going to also include that x minus 1 at the end. Here's another example of factoring a polynomial. Hopefully you can see that you actually do have perfect cubes now, not perfect squares, but perfect cubes. So we can still use an area model, but it's going to be a little bit different. It's going to be actually a 2 by 3 box. Now I can put my first term in the upper left and my constant in the lower right. The one thing to remember is because you do not have any middle terms, the diagonals that you're going to have inside your box as you fill them out will actually cancel out. And they must cancel because you don't have any middle terms in your original expression. So what I'm going to do is I'm going to put the cube roots on the left-hand side of your box. So 8x cubed is 2x, and then the cube root of negative 27 is a negative 3. So once I have the left-hand side of my box filled out, you can then utilize and kind of play like a Sudoku puzzle and figure out what goes in the remaining top columns or in the inside of my box. So if I have 2x, I know I can multiply 2x by 4x squared to get me 8x cubed. Once I have the 4x squared, I can then get the negative 12x squared. That diagonal has to cancel, and I would get an opposite, so a positive 12x squared. Then I can fill out the top of my middle column, which is 6x. I can fill out the lower middle box. Gets me negative 18. And again, the diagonal of that negative 18 has to cancel, and that would be a positive 18x. And again, filling out the right column at the very top, I would get 9. And again, 9 times negative 3, yes, does get me that negative 27. So I'm going to write the left and the top of my box as my 2 factors. And you're done. So here are some things to remember. Whenever you have 4 terms, you are always factoring by grouping. And then when you see that you have perfect cubes, whether it's a sum or a difference of perfect cubes, you can use the 2 by 3 box to help you to factor. I hope you found this video helpful and you've become experts at factoring polynomials. Thanks for watching and have a great day.